Thank you very much to CEFIPRA for granting us this project proposal on morphologic assessment of water resources, semi-arid catchment of Central India. So this project was funded to us in 2020-22, and where main objective of this project was to assess groundwater resources and do budgeting of groundwater in semi-arid river catchments. So under this project, we have recruited one student. He is currently doing PhD, and we have also established an observatory in in a remote location at the border of Madhya Pradesh in Rajasthan, place called Sanwara. So there we have installed three piezometers, so where we record water level at every 10-minute interval, and then we have established one weather station on the rooftop of primary school, which is there in the village. So that records temperature, precipitation, humidity at same interval, 10 minutes interval. And also we have several sensors installed for the soil moisture measurement. And time to time we go to the field depending upon the flow condition in the river, and we record the discharge for 5 days, 6 days. And this measurement we do at every after 3 years, 3 months, 4 months in the field. So this study is mainly field-based study, and we are also doing at the same time experimental study that is done in IPGP in Paris, Institut de Physique de Globe de Paris. So where they have a small scale experiment, and there they try to simulate catchment and the response of catchment due to change in rainfall and change in groundwater level regime, and how topography adjusts to changing water level in the system. So I'll take your few minutes, and we have set up a similar kind of observatory here also in our campus in Bhopal. That is partly supported by the fund that we got from CEFIPRA and partly from our own resources. So if you want to have an idea what exactly we are doing in our catchment, I will be happy to show you in this what we have set up. So the French team, they have expertise in small scale experiments, and which is very unique. It is done at only few locations, and IPGP, where my collaborator works, is one of the pioneer institutes, and they are expert of conducting small scale experiments. Small scale experiment becomes essential sometimes when we don't want to spend more time in doing experiment. So in a small scale, the equilibrium at which we want to make measurements can be attained within a day or so. So that is good in a way that we don't spend much time. And also this I have a past experience in working with the PI, because I was this former PhD student, and we have a good understanding. So for this collaboration that is needed, especially in international collaboration, where you have a prior understanding about PI, that can be very helpful in our education project. So the global issue, so particularly, is an issue, especially in dry lands. For example, in India also we have a large portion that falls under semi-arid condition and arid condition, and where groundwater stability and the surface water availability is challenging. So through our study, we know that we will learn and will get to know that what happens after a rainfall event. So rain is, as you know, that in India we have a heavy monsoon system. So how much water infiltrates into the groundwater, and then how this groundwater releases into the surface water in form of stream flow. So if we have estimate how much water we are getting from rainfall and how much water we are releasing, so that kind of water budget will be very important for the water resource in dry lands. So this is the ultimate outcome of our studies. To best of our knowledge, we have not seen this kind of study which has been conducted elsewhere to that level of details. So our study is mainly, as I told you, based on the real-time measurement in the field, and also getting the information from small scale experiments. Some studies has been done based on numerical model, but I cannot comment more. Yes, so this is the this will help in sustainable development also to achieve sustainable development goal, because the water management, efficient water management in these regions is challenging. The understanding that we will get from this study will help us to minimize the water usage, water losses in terms of surface water loss due to evaporation, groundwater depletion. So overall, this will provide a solution for sustainable management of water. Yeah. So let's go. Yeah. So this is an example of experimental table that we use to conduct different kind of experiments. So for example, here this is the water tank where we maintain constant head. So we know that my discharge at the outlet is, or at the outlet of this tank is constant. And then we, based on our requirement, so we can perform how the river adjusts its width, how river changes in response to change in the sediment transport regime. So all those experiments we can conduct, and also we can conduct how catchment respond or change in groundwater level respond to the catchment topography. So all these experiments we conduct here, and a similar kind of experiment, even more advanced version of experiment we are conducting at IPGP in Paris. Yeah, so this is a similar kind of observatory that we have established in the Sanwara catchment, which is at the border of Madhya Pradesh and Rajasthan, which I told you. That was supported through CEFIPRA, and for this observatory, it is partly supported by CEFIPRA and partly from some other projects. So the similar kind of measurements we are making. So for example, here what you see is the pan evaporimeter. So that gives us information about the evaporation, how much water we lose in response to evaporation. So there we have weather stations that we record rainfall, temperature, humidity, wind speed, and all those things. And then there we have installed different soil moisture sensors at different depths, so that we know that how soil moisture retain into the soil. And once you have all these measurements, so this small instruments which you see here is a infiltrometer. So basically we do infiltration experiments. So at what rate water infiltrate into the ground, okay? So all these informations are very important to do the water budgeting, because for water budgeting, if you know how much rainfall is coming, how much rain we are losing in response to evaporation, evapotranspiration, and then infiltration, then we can say that how much water is left, how much water recharges into the ground. And then at the same time, if you have measurement from river discharge from the river, and you know that these in semi-arid river catchments, most of the time river discharge or river flow other than monsoon is dominated by the base flow. So base flow means the water is coming from the groundwater released into this system, into the river. And once we have the estimate of all these things, we can make better management of how much water resources is available, how much we are losing, and accordingly we can plan. Further, this study can help us to combat the climate change effect. So how the climate change is going to affect our water resources. So if we have all these estimates, we can accordingly conduct, we can simulate for a given climate change, and if this is the climate change projection, how my water resources is going to respond. So this is also a important study for the climate change. Yeah. So one thing I would like to highlight about catchment, Sanwara catchment, where we are working. So this completely comes under the dry region, and precipitation is approximately 930 millimeter per year. And you'll see that surface water availability in the catchment is only during the monsoon, and after monsoon you can have water in the river and lakes for about more than 2 months till November. And after that, surface water is completely dried up. Rivers are dried. There is no surface water available. The main source of drinking water in the catchment is they have dug well. So that is the main source of drinking water, and also in deep aquifer the water table is very very deep, approximately 400 meters. So there are some tube wells that has been drilled to 400 meters. So you can see that, and the main problem in that area is that especially for the animals in summer, as I told you, there is no surface water available. So you'll see in summer many animals dying on the many dead animal you can see in the catchments, and this is mainly because of there is no water to drink. So in this project, we at least we are planning to give some help and some suggestion that where to build uh, storage for surface water so that water can be available for animals during the summer season.
So my name is Abdul Khalik. I'm a PhD student at IISER Bhopal. So I'm currently working on groundwater dynamics in the Sanwara catchment and also the surface water groundwater interactions. So I'm using geophysical data, mainly CVT data, and hydrometeorological data like groundwater fluctuation and rainfall and other weather parameters to uh, estimate the water budget in the Salwara catchment, because it is a very complex system there in the hard rock terrain. So we have to quantify how much water is coming in the catchment and how much water is going to the outlet. So since it is a small catchment, so we can use this catchment as a model for groundwater budgeting.
Long live India and France friendship.